Hello students, welcome. Myself Swati Hegde. In this class, we are starting one of the very important chapter in your first PUC syllabus, that is redox reaction. You are already familiar with oxidation reaction and reduction reaction, but I think this is new for you, redox reaction. What is this redox reaction? What are the concepts which we are going to study in this chapter? Let's discuss one by one, okay? First, let's discuss what are the important things which you are going to study in this chapter. After that, we'll take one by one, okay? First topic which you are going to study in this chapter is classical concept. Classical concept. What is this classical concept? That means old definitions of oxidation, old definitions of reduction, and which are the theories that and all you are going to study in classical concept. Next is electron transfer theory. Electron transfer theory. This is very important topic, electron transfer theory. All this chapter is based on your understanding in this topic, okay? Yeah. Next, third topic is oxidation number. Oxidation number. Oxidation number. And fourth topic is types of redox reaction. Types of redox reaction. Types of redox reaction. There are different types in redox reaction which you are going to study under this topic. And fourth one is balancing redox reaction. You will hear in this concept you will get some random reactions. That means redox reactions only. You have to balance it, okay? Balancing redox reaction. Balancing redox reaction. So there are two methods in this topic, mainly two methods in this balancing redox reaction. One is by oxidation number method. Oxidation number method. Another one is half reaction method. Half reaction method. One in balancing redox reaction, you can balance the redox reaction by using two methods. One is oxidation number method, another one is half reaction method. For all this is the basic, very basic concept, okay? You have to concentrate mainly on these two topics, okay? Yeah. Next one is redox reaction and electrode process. This is last topic, redox reaction and electrode process. Electrode process. Okay, these are the main topics which you are going to study in this under this topic, redox reaction. First is classical concept. Under classical concept, you will study what are the old definitions of reduction, what are the old definitions of oxidation, and in electron transfer theory, you will study the movement of electrons during redox reaction. And in oxidation number, you have to find redox reaction or whether element is undergoing oxidation or reduction, you should study its oxidation number. It's very important topic. And next is types of redox reaction, and fifth topic is balancing redox reaction. There are two different methods for balancing redox reaction. One is oxidation number method, another one is half reaction method, and sixth one is redox reaction and electrode processes, okay? So let us start with classical concept. So if you see this heading, redox reaction, see the first word, redox. What is that? It's a combination of two words, redox. See, let me write it. Redox. It is a combination of two words. One is reduction and oxidation. Reduction, and this OX represents oxidation. So reduction and oxidation simultaneously takes place in a reaction to form redox reaction. ನಿಮಗೆ ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಆಗಬೇಕು ಅಂತ ಆದರೆ ಅಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ಆಗಬೇಕು, ರಿಡಕ್ಷನ್ ಆಗಿರಬೇಕು. ಐ ಮೀನ್ ಒಂದು electron na ಕೊಡ್ತಾ ಇದೆ ಅಂತ ಆದ್ರೆ there should be another element which should accept electron. So oxidation ಮತ್ತೆ reduction ಎರಡು ಆಗ್ತಾ ಇರುತ್ತೆ, ನೀವು ಮುಂದೆ ಹೋದಾಗೆ ಅರ್ಥ ಮಾಡ್ಕೋತೀರಾ ಅದನ್ನ. Okay, first remember this redox is a combination of two words, that one is reduction, another one is oxidation. In your high schools you have already studied the definition of oxidation and reduction. Let me brush up those things. Yeah, first is oxidation. Oxidation. What is oxidation? ಏನು oxidation ಅಂದ್ರೆ there are four main definitions for oxidation. Okay, first one is oxidation is addition of oxygen. Oxidation, I mean we are adding oxygen. Oxidation, addition of oxygen. Addition of oxygen is oxidation. Example, you can take any example. Let me give example for synthesis of magnesium oxide. Mg will react with O2 to form MgO. Okay, this is not balanced reaction. You can balance this. Mg plus O2 MgO. Here we are adding oxygen to magnesium. Oxygen O2 reacts with magnesium to form MgO. So initially there was no oxygen with magnesium. When it reacts with oxygen, it will add with oxygen. Okay, we are adding oxygen with magnesium. This is addition of oxygen. So what is oxidation? One definition is addition of oxygen is oxidation. As you know, this oxygen is electronegative atom. This is not only oxidation. In oxidation, you cannot say it's only addition of oxygen. So it can be addition. The second definition is it may be addition of electronegative atom also. Addition of electronegative atom. Addition of electronegative atom. Addition of electronegative atom is also oxidation. Let me take same example, magnesium, reaction of magnesium with fluorine, F2. Fluorine is electronegative atom. In the whole periodic table is the most electronegative element, and if it reacts with magnesium, you will get MgF2. So addition of oxygen is oxidation, or addition of electronegative atom is also oxidation. And we have one more definition, that is, I'll write it here, third definition, that is removal of hydrogen. So here addition of oxygen, here removal of hydrogen. Removal of hydrogen is also oxidation. Removal of hydrogen. Removal of hydrogen is also considered as oxidation. Let me take example of methane, CH4. Methane reacts with O2 and it forms CO2 plus H2O. See, here we are removing hydrogen from carbon. That is removal of hydrogen. Removal of hydrogen is also oxidation. And fourth definition of oxidation is addition of electropositive atom. Addition of electropositive atom. Addition of electropositive atom is also oxidation. So I'll give an example for this. Sorry, this is not addition, this is removal of electropositive atom. Removal of electropositive atom. Removal of electropositive atom is also oxidation. Example is K4FeCN6, that is potassium ferrocyanide. When it reacts with H2O2, it will form K3FeCN6 plus KOH. Okay, so this is removal of electropositive atom. Here potassium is electropositive atom. See, there are 4 potassium here, but when you see product side, there are only 3 potassium in this reactant. Okay, so removal of electropositive atom is also oxidation. Here we have studied 4 definitions for oxidation. First one is addition of oxygen. Addition of oxygen is oxidation or addition of electronegative atom, or removal of hydrogen or removal of electropositive atom. These are all the definitions which you have studied in your earlier classes. Okay, you should remember all these definitions. What is oxidation? Oxidation is addition of oxygen or addition of electronegative atom or removal of hydrogen or removal of electropositive atom, and these are all definitions for them. Okay, next is reduction. Oxidation is over. We are studying only classical concept now. Electron transfer theory will study that theory later. Okay, next is reduction. Reduction. What is reduction? What will you study in reduction? This is directly opposite to that of oxidation. In oxidation, we have studied first definition, addition of oxygen, but here it is removal of oxygen. Removal of oxygen. Removal of oxygen is reduction. Remember, in case of oxidation, we have studied addition of oxygen. This is exactly reverse to that of oxidation, that is removal of oxygen. Example is for HGO. HGO. It will dissociate into Hg plus O2. Okay. So here I am removing oxygen from mercury. So I am removing oxygen from mercury, that is removal of oxygen. Removal of oxygen is reduction. And second definition is removal of electronegative atom. Removal of electronegative atom. Removal of electronegative atom is also reduction. Removal of electronegative, example for removal of electronegative atom is FeCl3. You can take example of FeCl3. When FeCl3 reacts with H2, it will form FeCl2 plus HCl. Here chlorine is electronegative atom. I am removing chlorine from iron. Here there are 3 chlorine and here there are 2 chlorine atoms. Okay, I have removed 1 chlorine from this. This is removal of electronegative atom. Here I have removed oxygen. In second example, I have removed electronegative atom. So removal of oxygen is also reduction. Removal of electronegative atom is also reduction. And next definition is third one is addition of hydrogen. In oxidation, we have studied removal of hydrogen, but in reduction it is addition of hydrogen. Addition of hydrogen. Addition of hydrogen. You can take example of ethene here. CH2 double bond CH2. When this reacts with H2, it will form CH3 single bond CH3. See, this is example for addition of hydrogen. I am adding one hydrogen to each carbon atom. Okay. Next, fourth definition is addition of electropositive atom. Electropositive atom. Addition of electropositive atom is also reduction. You can take example of Hg. HgCl2 reacts with SnCl2 and it forms Hg2 Cl2 plus SnCl4. These are all not balanced reaction. You should balance this. Okay. So this is addition of electropositive atom. Here mercury Hg plus 2 is electropositive atom. See, in product side you can see one more Hg. So all these are definitions for reduction. What is reduction? You can even see removal of oxygen is reduction, or removal of electronegative atom is reduction, or addition of hydrogen is reduction, or addition of electropositive atom is also reduction. So you can compare the definition of oxidation and reduction. Oxidation is addition of oxygen, reduction is removal of oxygen. Oxidation is addition of electronegative atom, but reduction is removal of electronegative atom. Oxidation is removal of hydrogen, but reduction is addition of hydrogen. Oxidation is removal of electropositive atom, reduction is removal, addition of electropositive atom. Okay, so these are all simple definition, very simple, no need to remember all this definition, or you should remember, but these examples are okay. If you want, you can remember, or else no need. Okay, yeah. Next is one of the very important concept in this redox reaction, that is electron transfer theory. Electron transfer theory. This redox reaction always associates with electron transfer. That means redox reaction is accompanied by electron transfer. Yaude ಒಂದು redox reaction ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಅಲ್ಲಿ electron transfer ಆಗಲೇಬೇಕು ಒಂದು atom ಇಂದ ಇನ್ನೊಂದು atom ಗೆ. So next is electron transfer concept or electron transfer theory. Electron transfer theory. Okay, in electron transfer theory, or if you consider any reaction, redox reaction, let me consider A and B. Electron will transfer from one atom to another atom. Before going to this, let us learn an acronym, that is LEOGR. LEOGR. What is this LEOGR? LEOGR. So, loss of electron oxidation. Loss of electron. Loss of electron oxidation. LEO. Loss of electron oxidation and gain of electron reduction. Okay. Here, gain of electron is reduction. You should remember this acronym. Loss of electron oxidation, gain of electron reduction. So this LEOGR, if you remember this, you can easily say which atom is undergoing oxidation and which atom is undergoing reduction. LEOGR, loss of electron oxidation, gain of electron is reduction. Okay. Now here electron is transferring from A to B. Transfer of electron is taking place from atom A to atom B. So that means atom A is losing its electron. That means loss of electron is oxidation. That means A is undergoing oxidation. Oxidation is taking place at A. Okay, A is said to be oxidized. You can even say at A oxidation is taking place and A is said to be oxidized. A is said to be oxidized. B is receiving electrons from A. See here, gain of electron is reduction. So B is gaining electrons. So at B, reduction is taking place. At B, reduction is taking place. At B, reduction is taking place and B is said to be reduced. B is said to be reduced. So here A is donating electron or it's losing its electron and it is said to be oxidized. Oxidation is taking place at A and B is receiving electrons from A and it is said to be reduced. See here, we are adding electron to B, but we are saying it is reduced. Reduced means ಕಡಿಮೆ ಆಗೋದು ಅಂತ. ಬಟ್ ನಾವಿಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಬಟ್ ಏನಾಗ್ತಾ ಇದೆ, ರೆಡ್ಯೂಸ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೀವಿ. ವಾಟ್ ಮೇ ಬಿ ದ ರೀಸನ್ ಫಾರ್ ದಿಸ್? ಸೊ ವಿ ಆರ್ ಆ್ಯಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟು ಬಿ ಆ್ಯಂಡ್ ವಿ ಆರ್ ಸೇಯಿಂಗ್ ದಟ್ ಇಟ್ ಇಸ್ reduced. See, what's the charge on electron? Charge on electron is -1. Okay, so initially there is no charge on B. Initial charge on B is 0. Now I have added one electron to B. Now the charge will become 0 plus -1, that is -1. The charge has been reduced to -1, 0 to -1. Now I'll add one more electron to this. The charge was already -1. I'll add one more electron. That means -1, -1, that is -2. If I add one more electron, charge on electron is negative, -2, -1, that is -3. See, on adding electron, the charge on the atom will reduce. Since electron is negatively charged, the charge on this atom which is accepting electron will be reduced. So this is called as reduction. Okay, don't get confused with this, because since we are adding electrons, it will not oxidation. It is not oxidation. We say it as reduction because charge on electron is negative. Since we are adding negative charges, this negativity decreases, negativity increases in this. That means charge decreases, 0, -1, -2, -3. Charge will decrease. So we will call this as reduction. Okay. So here A is transferring its electron to B. We'll say A is oxidized because it's losing its electron, and B is gaining electrons, and we say B is reduced. Okay. Yeah. Next, let us consider an example of formation of NaCl. You are already familiar with NaCl. NaCl, formation of NaCl. Here what will happen? Na will react with Cl and it forms NaCl. Na plus Cl minus. Sodium will react with chlorine and it forms NaCl. You can write NaCl or Na plus Cl minus. Okay, there is no difference between Na plus Cl minus or NaCl. Yeah. Now here sodium is donating its electron. Electron is transferring from sodium to chlorine. Electron transfer is taking place from sodium to chlorine. So it is forming Na plus, and Cl is receiving one electron and it forms Cl minus. At Na is losing electron. So it is, Na is said to be oxidized. Oxidized. Na is losing its electron. It is donating its electron to chlorine. Na is losing its electron and it is said to be oxidized. Now I will take chlorine. Chlorine is receiving electron. Receiving electron. So it is said to be reduced. It is said to be reduced. Okay. So sodium is losing its electron and it is said to be oxidized. Chlorine is receiving electron. Loss of electron is oxidation. Gain of electron is reduction. Okay. Chlorine is reduced. See, sodium is donating its electron and it's forming Na plus 1 electron. Sodium is losing 1 electron. Okay. But chlorine is receiving 1 electron. Cl, initially it was Cl, it will receive 1 electron and it forms Cl minus. It is receiving electron. This reaction is called oxidation half reaction. This reaction is called oxidation half reaction. Here sodium is getting oxidized. Sodium ಏನಾಗ್ತಾ ಇದೆ? Oxidize ಆಗ್ತಾ ಇದೆ. Sodium is getting oxidized. So this is oxidation half reaction. Oxidation half reaction. What is oxidation half reaction? The reaction, half reaction which contains, or the reaction in which an element loses its electron is called as oxidation half reaction. So this is reduction half reaction. Here element is receiving electron. It is receiving an electron. You know, gain of electron is reduction. So this reaction is reduction half reaction. Reduction half reaction. Reduction half reaction. So Na will lose 1 electron and it will form Na plus and 1 electron. So this is oxidation half reaction in which the element will get oxidized. And reduction reaction is the one in which element will be reduced. It will receive 1 electron and it will get reduced. Okay. So if I combine these two reactions, I will get Na and plus Cl forms NaCl. Electron will get cancelled, okay, here. So Na plus Cl gives NaCl. This is not balanced reaction. You will not get Cl. Let me write the balanced reaction now. So how will you balance this reaction? Balancing this redox reaction. Na plus Cl2, it will form NaCl, or let me write it here. Okay, Na plus Cl2 gives NaCl. Cl2, there are two Cl atoms, so I'll write 2 here, 2 NaCl and 2 sodium. So here sodium is losing 2 electrons, it is forming Na plus, right, Cl minus. Na is forming Na plus, but there are two sodium atoms, so it is forming 2 sodium ions by losing 2 electrons. Loss of 2 electron is taking place. It is losing 2 electrons. Sodium is losing 2 electrons. That 2 electrons will be gained by this chlorine. Gain of 2 electrons. Gain of 2 electron, that means it is undergoing reduction. Chlorine is receiving electron and it is undergoing reduction. Chlorine ಏನು ಮಾಡ್ತಾ ಇದೆ, electron ನ ತಗೊಂಡು reduce ಆಗ್ತಾ ಇದೆ. Okay, so this is electron transfer theory. What will happen during oxidation or during redox reaction? One element will donate its electron and another one will receive electron which is donated by other atom. Okay, so next is competitive electron transfer. Let us take a beaker which contains copper nitrate solution which will be blue in color. So what's the reason for blue color of this solution? That is Cu plus 2 ions. Cu plus 2 ions are blue color in nature. CuNO3 twice, copper nitrate solution, and let us dip a zinc rod in this. This is zinc rod. Initially it was blue in color, but if you keep it for some time, it will change into a colorless solution. This will change to a colorless solution and you can see a red deposit on this rod, that is copper, deposits of copper. Okay, initially copper was at plus 2 oxidation state, CuNO3 twice, Cu plus 2, and zinc was at oxidation state 0. Since it is a metal, you will understand, you will learn how to find this oxidation number in next session. Okay, so zinc was at 0 oxidation number. After reacting with copper, what will happen? Copper from the solution will enter into metallic state and it will become Cu0, and zinc will receive electrons from copper and it will become Zn plus 2. Sorry, zinc is donating electron to copper and it is becoming Zn plus 2. Here loss of electron is taking place. Loss of electron is taking place from zinc and copper is gaining electron. Gain of 2 electron. That means zinc is undergoing oxidation and copper is undergoing reduction. See, if you pass H2S to this solution, colorless solution, when H2S is passed through this colorless solution, it will react with Zn plus 2 and it formed ZnS, which is white color precipitate, white PPT. So formation of this white PPT indicated that zinc entered into solution state and it formed Zn plus 2 ions. Okay, here copper is donating electrons to, copper is receiving electrons from zinc. Copper is receiving electrons from zinc. Zinc is donating electrons to copper and it is becoming Zn plus 2. Copper is receiving 2 electrons from zinc and it is becoming metallic copper. Okay, so you can see the metallic copper deposition on this rod. If reverse reaction is done, you cannot see this copper ions in this solution. Okay, when zinc sulfate solution is taken, which is a colorless solution, and when you dip copper rod into this, copper will not enter into solution state, which was determined by passing H2S. If there was copper, it will form black color precipitate, but you will not get any black color precipitate. That means only your zinc can donate electron to copper. Copper cannot donate electron to zinc. In the same way, by taking silver nitrate solution in the beaker, this is silver nitrate AgNO3 solution, which is a colorless solution, and by dipping copper rod in this. Initially it was AgNO3 is a colorless solution, but if you keep this for some time, you will get blue colored solution. Intensity of blue color increases. Initially it was colorless, but after some time it will get colored due to the presence of Cu plus 2. I dip copper rod, but after certain time what will happen? Copper will enter into solution state and silver will deposit on this rod. That means in this case Cu, initially Cu was at 0 oxidation state, and Ag plus 2Ag plus, they will form Cu plus 2 plus Ag, metallic silver. So this is the reaction. That means here which one is donating electron? See, 0 to plus 2. That means copper is donating electron to silver. Copper is donating electron to silver, and charge on silver is getting reduced. That means only zinc can donate electron to copper. Copper can donate electron to silver, but the reverse is not true. This series is called as spectrochemical series, arrangement of atoms according to their electron donating tendency. Okay, so that is called as spectrochemical series. So that completes this topic. Next is oxidation number. Let us study that in next class. Thank you.